Assalamu alaikum. Good evening. Today, we are sharing a success story for implementation of EIRMS management system for Dragon Oil, where AI features are also being used. In this agenda, what I will be covering, like a partnership between Velosi and Dragon Oil team, then the benefits, what we achieved for this partnership, then how we achieved the target for implementing this AIM system, then what we finally achieved, and how we are advancing towards the use of AI features in future. About partners, so Dragon Oil basically is one of the major oil producing company in Turkmenistan and Egypt, and we have basically implemented our VAIL-Plant software system and AIM system practically for their Turkmenistan operations. Velosi, we are one of the asset integrity, HSC, engineering services and software solution providers in the world, and we got footprint in almost over 70 countries. We are present in all Middle East countries, and we provide services to oil and gas sector, nuclear sector, construction and energy sector. And we have successfully completed over 700 projects, like in asset integrity, over 200 projects in HSC side, and about over 300 projects in basically engineering, and about 50 projects in software implementation. So what we achieved basically as a approach point of view, like implementation of IDMS software, which is basically PIMS, like a pressurized equipment management system, a pipeline integrity management system, structural integrity management system. Then we also basically added PSVMS, EIRMS modules on the VAIL-Plant later on for the other assets. Then we also worked with basically Dragon Oil to implement ISO 55001 system. Under that system, we developed AIMS manuals, procedures, and also the documentation which was required to be followed for the ISO 55001 documentation. The ISO 51000 a certification is done by another third party, whereas we provided the consultancy services and the documentation requirement to achieve that certification objective. Then development of OPM and company system and procedure we did, updating of the basically PIMS like a pipeline management system, integrity, pressurized equipment management system, structural integrity management system, electrical and instrument rotary equipment management system, PSVs management system, and then we have added other assets like GOST, CPSF, then DAJA, tank farm, ZHDA and ZHD25 and LAM28, and then artificial intelligence features also have been added over the period. Like what we have achieved so far as a part of asset integrity management system. So the overall documentation is prepared in line with ISO 55001 requirement, and those documents are implemented, trainings are provided, and it is adopted by the Dragon Oil organization as a culture. Then while implementing AIM studies, so we have executed various studies like risk-based inspection study, RCM study based on FMECA, then pipeline integrity management studies, and SIL studies. So where we also went for HAZOP, and then implementation of the asset integrity management software solution as a part of the all assets within the most of the assets, I would say, in Turkmenistan, basically Dragon Oil operations. So up to now, we have covered almost 20 offshore platforms for Dragon Oil Turkmenistan, which takes the tags of 50,477 and 45 pipelines, out of which 42 are from offshore side and 3 are from the onshore side. And altogether, total length of this pipeline is 134 kilometers. And then we have covered various asset types like static equipment, piping system, rotating equipment, electrical equipment, instrumentation, PSVs. So together they are making total constitute of 15,477 tags. How it is achieved? So first, what we did, like AIMS point of view, registration and verification of assets. Then we did inspection and maintenance history recording, then failure and anomaly recording, then inspection and maintenance history recording, then risk assessment, then development of inspection and maintenance plans, then asset passport and reporting, then asset performance management model has been updated to predict any kind of trend on the failure side, risk side, or eminent life side. Similarly, for ISO 55001 implementation, what we did, the first, we did the gap assessment of the existing system. After gap assessment was established, we have prepared the documentation to bridge those gaps. So it means preparation of AIM documentation, then implementation of AIM system training, then preparation audit for the ISO 55001, and then final ISO 55001 certification. Similarly, we have prepared the import templates for SAP as a CMS system, and to reach that, we have prepared the asset register, then and development of hierarchy in accordance with ISO 14224 standard. So we have basically also visited, performed surveys for the Dragon Oil offshore assets for the site validation and asset register verification. Then FMECA analysis, RBI analysis has been done for the asset as it was applicable. Then development of maintenance strategy, then development of a PMR or task list and maintenance routines, then implementation of SAP system overall. So in this way, if you can see that, starting from the implementation of ISO 55001 system, then SAP data loading, and to support and to complement, we have implemented VAIL-Plant software system, which is Velosi software system, proprietary software system, which covers various modules, and these modules help to achieve asset integrity and trending and AI features. Achievement-wise, if you see here, for example, as a part of PIMS system, so we have covered almost 19 facilities, covering 376 equipment and 3,976 piping tags, where we did risk, basically categorization, then remnant life assessment, then inspection and PM activities, and then leaks, detects, and the replacements. So in this way, we have done basically total tags here, component tags basically, then RBA studies completed, then RCM studies completed, right? And in this way, we have basically covered the PIMS system and the AIM system. Next, inspection history recording, if you can see that for the static equipment and piping system and tanks, the various kind of inspection activities like entity inspection, visual inspections, advanced entity inspections. So all those records have been saved in the system, and in an intelligent way we're able to see the trend. Then we have covered risk assessment part. We prepared through loop drawings. Then we also prepared the asset passport report for each particular equipment. Here, various kind of trends which we can see through the system is if it is a number of leaks, number of basically trips, or number of anomalies or kind of anomalies, remnant life, metal loss, or the risk side. So all these trends are available, which we can drive through the AI feature as well. In those detailed inspection routines, we prepared various applicable entity techniques, TML, CML drawings, and mechanical access, H2S caution, and those aspects we are prepared as a part of detailed inspection plans, written scheme of examination for these equipment. So these are some sample screens what we have used as in the system, and these are configurable and can be updated. Similarly, we have prepared PIMS, which is a pipeline integrity management system, both for onshore and offshore, basically the risk side, reliability side, and the trends what we wish to see. Then here is the pipeline route layout drawing, where various damage mechanisms and their threats are identified along the route of the pipeline. Then here we have done section-wise a risk-based inspection assessment of the pipeline based on each section. Applicable damage mechanisms are considered, and their growth rate is assessed, risk is assessed, then accordingly inspection planning is done on each sectional level basis. So here you can see like inspection history of the pipeline again along the route of the pipeline for KP side, whether it is a DCVG survey, whether it is ROV survey on the offshore pipelines, or there could be for example, if there could be a free span, or there could be a damage of any node on the offshore, or there could be any defect at any location. Those are identified, and those defects are assessed as per the applicable like a Shell, DNV, or like ISMS B31G code and standard, right? And here is the result again, where we have the history, the risk assessment in terms of drawing what we have prepared. Third system, if you see it, this is a structure integrity management system. In structures, like we have covered almost 20 offshore structures with 24,596 components. And these structures, basically, we have done like a marking of the tags and components on the drawings. Then we prepare the asset register. Then on each asset register, we have done probability of failure and the sequence of failure calculations based on the applicable criteria given in API to SIM. And then after the risk assessment aspect, because we have developed basically inspection planning and inspection interval as well. So here you can see there are marked drawings there, and then the passport also is prepared for each platform separately. And here is you can see the inspection history recording and the trend and the future inspection plan as well. And we have used FMEC approach to do risk assessment, failure mode analysis, and future inspection planning or maintenance planning of these PSVs. So we have used this. These are sample screens around your view. So we also prepared like a passport and like a future inspection plan for each PSV, and history recording or the maintenance recording or functional like bench testing or the other tests which could be conducted for the PSVs are also recordable in the system. Next, like we have used our EIRMS model, which is basically RCM model for the development and implementation of like PM routines, task lists, job plans, and also the failure mode and defect analysis is done by using the same software. And then the analysis results and the given recommendation are converted into the PMs and job plans, and those PMs and job plans are uploaded into SAP along with the PM activities, the craft and man hours, and required basically the VUM for each activity is also defined there. So here if you see that this is the sheet on the right side, which is FMECA analysis for one of the equipment, detailed inspection plan, how it could be basically maintenance could be done as a practice. SAP data loading. So all this data finally has been uploaded into SAP, where the PMs are being done and the work order, the generation system, and their performance monitoring of the PM activities is being monitored by SAP. So it's a combination of VAIL-Plant and SAP system. So last but not least, the APM system, which is the combination of overall system, including SAP and PyHistorian, where we can see the various kind of trends of like whatever configuration we wish to have. For example, if we wish to see high risk items, so we can configure high risk items, or equipment with lesser remnant life or more remnant life. We can also see the equipments are having with various kind of anomalies can be identified, or anomalies trend can also be seen. And similarly, work orders, pending work orders or work orders executed, inspection plans executed or pending. So these all aspects can be seen via the APM module using the AI feature as well. So here if you can see that we have RLA, metal loss, corrosion rate, anomalies, risk distribution results, MTBF and MTTR, bad actors, PyHistorian, like us, then sensor data, then condition monitoring data, and work order status can be seen via APM module of the VAIL-Plant. We also have ISMS, which basically is a mini schedule management activity. Like if you don't wish to use like a SAP, then we have built a module in VAIL-Plant along with the CMMS feature of the VAIL-Plant. We also have a CMMS feature. If we don't want to use SAP, we have a full-fledged system, including all asset integrity modules, plus CMS system and plus ISMS. ISMS is inspection schedule management system for the inspection activities, where this model is linked with all other supporting models and with the database, asset register, inspection activities, and these inspection activities where work order could be generated by this system, and the activities can also be monitored and closed by using ISMS system as well. So this way we completed, and now advancing asset integrity through AI innovation. So that is the next stage where we are now working with Dragon Oil, like how the current databases, the trends, and the features which are available in our software system could be used more effectively through AI feature as well. So in normal definition, like we know that like artificial intelligence mean like a feature what human being can use. So the computer machines analogs can also be configured to do the basic activities. In general, the AI activity started like which is called Turing test by Mr. Alan Turing in 1950. So it means that AI feature is not new, and it is a basically human and machine interface or HMI interface. If we can use it more effectively, then we can use this knowledge for the better management of our assets, and we can predict what may go wrong, and then accordingly we can take preventive action before failure occurs. See, like if we try to correlate AI and asset integrity, what is asset integrity as such? Design integrity, then technical integrity, and operational integrity. When you say design integrity, mean the things are designed in accordance with like international code and standards. Then we make sure they're designed, built, and commissioned in accordance with international code and standards. Then we have technical integrity, mean these assets are being inspected and maintained in accordance with the international standards and practices. And then operational integrity means everything which is being operated is kept within the operating limits. So if assets would be operated within IOWs, we call it integrity operating windows, then we can make sure like the relevant like threats would not be applicable. Otherwise, if any limit would be exceeded, then there's a potential consequence of that limit exceeding, maybe more corrosion, maybe more vibration. Like if a velocity of the fluid is exceeded more than a certain limit, it can cause more erosion corrosion. If let's say if a gas which is supposed to be dry, if it is a wet, more CO2 and water, then it can cause more erosion corrosion due to T-Ward-William equation. So in a way, if we can monitor those limits by using AI technique or by having certain alarms or certain alerts, so it can certainly help us to prevent certain effects. And that is the use of, or there is a combination of asset integrity objective and artificial intelligence basically practices. And here both systems can work more effectively, and then accordingly based on the good data sets, based on the good trends, we should be able to use AI in the betterment of the asset, effective asset management and operations. Like what we aim as a part of AI for the asset integrity management system, if we say, then it helps to automate any activity which is being repeated. So it will help to basically optimize that. It can make faster analysis. It can smoothly handle big data like IoT's data or by historian data, then improves process and workflows, perform risk and precise task efficiency, then reduce human interaction, improved accuracy, and it is available from the clock. So the general, like as everybody knows, is talking about, but the general objectives or benefits what we can focus while managing asset by using AI techniques. So then next thing is like if we have to forecast and prevent failures, enhance equipment reliability, it may help to increase productivity. It can help to reduce costs because if the failures could be averted, if trips could be prevented, if shutdown could be increase the profitability and productivity of the assets, and it may help to reduce the errors as well. Now, like what we are trying to do in the VAIL-Plant or software, they simplify the workflow, hands-free navigation, like what we are trying to, we have added a feature in our software called SARA. It is one of the AI feature where it helps to simplify the workflow, hands-free navigation. AI chatbot is also available, provide real-time insight, then manages tasks and with minimum basically human intervention. It helps to retrieve data on voice command. So this is one of the features which has been implemented, and we are promoting additional features as well. So we'll also be showing the SARA short video in the coming slide. So here, what we have, like artificial intelligence in VAIL-Plant, which is currently available, we have automation, then we have optimized maintenance planning, we have a remote monitoring and control feature, we have corrosion and fatigue monitoring feature, we have inspection and automation and analysis by the IoTs. Those IoTs or the sensors, the transmitters would have been available with the client, and then with the interface of PyHistorian or any historian data, we can take anomalies and we can help to take various decisions which could help to predict failures and increase the reliability of this. Like SARA bot is one of the activity. Like for example, if we wish to have any command by verbal command, or we wish to have just like in Google, we had various questions. It can help to find the relevant information from VAIL-Plant. Then it helped to asset monitoring site with the help of IoTs and sensors. Then with the right monitoring, it can help to basically improve HSE and integrity aspect of the assets as well.
Welcome to VAIL-Plant. Hello, I am Sarah. How can I help you today?
Sarah, can you open the PIMS module?
Sure, here it is.
Can you generate an inspection schedule for the main pipeline?
Task executed successfully.
Please show me the risk matrix of the ISMS.
Task executed successfully.
So this presentation basically we made jointly between Dragon Oil and Velosi, and jointly presented in SPE workshop last week. So I didn't have a recording, so I made the recording specifically to share on the YouTube or on our webpage. And in this basically session, since I'm presenting or recording only for demonstration, so we don't have a question answer session. However, in our webinars, we're used to have a question answer session and live interaction. So today I will be concluding this discussion. Thanks for attending it, for viewing it, and we look forward to have more questions through our webpage so as we can interact with you and assist you if you are interested to implement any AI-based asset integrity management software. Thank you.